Hi. Okay, today we're going to start our new lesson, 8M1, which is on exponents and powers. So let's look at what we're learning in lesson 2 specifically and how we apply the product and quotient rules of exponents and understanding when you can apply them and how to apply them. Let's go to our full screen share and let's hop to it. Okay, so let's look at how we, first of all, just really quickly, let's just always remember what we mean when we say 3 to the 4th power. That's simply telling us how many times this is our base and this is our exponent. So 3 to the 4th power means how many times do I repeat this base multiplying it this many times. So let's see that means 3 4 times, multiplied 4 times. 3 times 3 times 3 times 3, which equals 81. Okay, 3 times 3, 9 times 3, 27 times 3 is 81. So that's how we resolve these exponents. Similarly, we can use exponents with variables, and well, let's use a different one. Let's just say x cubed. So x to the 3rd power, we say this, x to the 3rd power, x to the 3rd power. That's how we say it. There's special words for x2 and x3. We could say x to the 2nd power or x to the 3rd power, but this is also called x squared, and this is called x cubed. So if you hear me say x squared or x cubed, that's simply shorthand for x to the 2nd or x to the 3rd power. So x to the 3rd power means x times x times x. Now notice here I use this multiplication symbol here. I use the dot notation. I could even use this notation. All of those mean the same thing. Okay, now let's get into the power, or sorry, not the power rule, the product rule. So this is called the product rule. Let me just switch colors so we know that we're going to a new section, the product rule. And we're not going to actually give you the rule right off the bat. Instead, I'm going to explain it to you, and you're going to deduce it like we did in class. So if we say, and you'll see some of the problem when we look at this is you're going to be thinking, because exponents are all about multiplication, that you might get confused on this rule. But let's not get confused as to how we apply the product rule, and we'll break it down here in a second. So if we say x squared times x cubed, a common thought would be to say that this is x to the 6th power, but it is not. And the reason is because x squared, if we break it out and we use our definition up here of exponents, we know that x squared is x times x. And we know that, and so here we're going to take down our multiplication sign here, and we know that x cubed is x times x times x. So we know that these two things are equal, and so by our definition of a power, right, 3 to the 4th, 4 is the exponent, 3 is the base, the whole thing 3 to the 4th is called a power. The whole expression is called a power expression. So by the definition of a power, this is equal to x to the 5th. And I'll leave it to you to go ahead and prove that this is true for any two variables multiplied by each other, if it's the same variable, with an exponent. So similarly, let's just do one more. Let's just say, we got x times x to the 4th. Well, remember, x is just like x to the 1st. It's x, there's just one x. It's not x multiplied any number of times. So it's just kind of, we think of this and I'll just make this a different color for a second, and we'll just say this is kind of like x to the first power. So if we bring this down, we get x. And if we bring this down, we get x times x times x times x. And so here we have x to the fifth power again. And the way that you can get it is you can simply, after you start to do enough of these, you can say, well, the rule is x to the anything plus, times x to the anything is x to the m plus n. And that's our product rule. That's our product rule of exponents. Product meaning multiplication equals multiplication. Right. So we can actually, this is pretty powerful, and this is one thing that you're going to do on your homework tonight, but let's keep going, and let's look at how we handle these things if they have some coefficients on them, and we'll see that it's all about using the definition of exponents to solve these types of problems. So let's look at a problem like 3y to the second times 4y to the third. Well, we're going to use this product rule of exponents, but we can just expand this out as well to solve this. And let's just see how we do it both ways. Let's expand it and then contract it. So let's see, we'll go, this is the same thing as 3 times y times y. That's the first piece. The second piece, I'll make this a different color. Let's just pretend this is 4. I'll draw this in blue. 4y cubed. So this is times 4 times y times y times y. Right? So that's the second piece. If you expand it out. Now I have expanded the whole thing. And so now what I'm going to do is I'm going to collect, because multiplication is commutative, I can just move everything around. Right? 3 times y is times 4 times y times y times y is the same thing as, and let's just pick some new colors, 3 times 4 times y times y times y times y times y. And this is true because it's commutative. Commutative property of multiplication. Okay, so now we know what 3 times 4 is. 3 times 4 is 12. And we know that the definition of powers says that this is y to the 5th power. Okay? So we can see that when we multiply powers, we simply do the same thing as we would do if we multiplied, say, 3x times 4x, and we get, that would be 12 times x, or 12x squared. We simply multiply our coefficients here. 3 times 4, there's our 12. And we use our product rule of exponents, y squared and y cubed, to get our y to the 5th. So I encourage you to stop the video right now. Just stop the video after I give you this problem and try this one. So I'm going to write it down. 2q cubed times 4q to the 4th. Now I want you to stop video and solve. Okay, I'll give you a chance to do that. Stop it and then solve, and then then I'll come back. Okay, now that we're back, I'm assuming you've tried to solve this. So the rule is, right? We're just going to rearrange our terms, and we're going to say, well, this is the same thing as 2 times 4 times q cubed times q to the 4th. I didn't expand it like I did up here, but I could and draw out our 3 q's and our 4 q's, but I'm not going to do that because we have learned the product rule. So this is 8 times q to the 7th. Right? So that is our product rule. Hopefully this made sense. We're going to now move on and we're going to do the quotient rule. We're going to do part of the quotient rule. And I'm going to flip our page here and we're going to start here with the quotient rule. I'm going to show you how to divide exponents. And I'm going to give you part of the rule, but not the whole thing. So quotient means division. That's the academic language word for division. So let's just start with an easy one, and let's just say, I don't want to say easy. It's easy for me because I know how to do it, but let's call it basic. This is kind of like your basic building block here, and we're just going to figure out how we go about solving a problem like this. So this is w to the 5th over w squared, and we're going to start by simply using our expansion, our definition of exponents, definition of powers. And we're just going to write out w to the 5th divided by w squared. Now, w squared, or w to the 2nd power. Now, if you remember, this should be straightforward. This would be the same thing as if we had 3 times 4 times 5 over, say, 3 times 4. We simply would do our canceling, and our answer would be 5. Here, similarly, we can just cancel. We'll just do our canceling, and we end up with w times w times w times w, or by definition of a power, w cubed. So w to the 5th over w squared is w cubed. Let's draw one more out so that you can start to see the pattern. And let's do x cubed over x. Now, x is the same thing as x to the 1st, as we recall from earlier in this lesson and earlier in our probably back in our building block section, we learned that. So let's expand this one as well. X times x times x all over x. So if we cancel and we cancel, we get x squared. Now, maybe just pause the video and see if you can figure out what the rule needs to be given these exponents. And then pause the video right now. So pause video. Right. So now that you've come back, you can see that the rule says well, let's just use x because we like to use x. X to the m over x to the n is equal to x to the m minus n. This is our quotient rule. Now, I prefer, at least for the unit that you're doing right now, you're going to need to not use this rule, but we're going to end up using the longhand version. And let me show you kind of a short longhand version of this. Let's solve this the way that you're going to need to do it on the homework. So the idea here is, you know that there's more w's on top than there are on the bottom. So we're going to rewrite this in terms of the bottom. So watch what I do. So I know that the bottom is w squared, w to the 2nd power. So I'm going to write the top as a w to the 2nd power times w to the 3rd power. Because I know, again, w to the 2nd times w to the 3rd is w to the 5th by our product rule. And notice what we have here. We have a very simple cancel. So we're just going to cancel these guys out, and we're going to end up with w cubed. The same thing as we did over here. but we didn't have to write out all 5 w's. We just wrote out our we broke out our w squareds, and then we separated off our w cubed. What I'd like you to do now is pause the video after I give you this next problem. And this next problem is going to be, what if we had x to the 4th over x to the 1st, or x to the 1st. Pause it and see if you can solve this one like we did the one above. Okay. Okay, now we're back. So hopefully you came and said, well, the bottom is x to the 1st because that's smaller. So on the top, I'm going to put down x to the 1st times x cubed. And then I'm going to take these guys and cancel them. And again, my answer is x cubed. And why am I not using this power rule? Let me show you a problem where this is going to come in handy, and you're going to have these on your homework. So let's say you had y to the 5th over y to the 9th. Now, in this case, the power rule is going to give you a negative number. And the negative number is okay, but we're not there yet. So we're going to simply use this rule up here, and we're going to say, well, this is the bigger number, so we're going to write down the smaller, the power with the smaller exponent on top, and we're going to rewrite the bottom now in terms of the top, and that's times y to the what power? Y to the 9th is y to the 5th times y to the what power? Hopefully you said 4, because y to the 5th times y to the 4th is y to the 9th. And in this case, when we come by we perform our canceling, we're going to end up with a 1 on the top, and our answer here is going to be 1 over y to the 4th power. Okay. And if we similarly, let's do this one. Let's do like x to the 11th over x to the 20th. You can pause and try this one on your own. And hopefully you get this, x to the 11th, because that's smaller. And the one on the bottom would be x to the 11th times x to the 9th. And then when we cancel, we get 1 over x to the 9th. Okay, now we need to do the same thing with this quotient rule that we did with our product rule, and that's going to be this. We need to know how to do 8x to the 5th divided by 2x to the 1st. Let's make it 2x to the 10th. Let's make this interesting. I think we're good enough for that. So now we're simply going to do it like this. We're going to say 8 times x to the 5th over 2 times x to the 10th. And we're just going to put together some rules that we already know. So we're going to leave this as 8 and 2 for now. On the top, we're going to put our x to the 5th. And on the bottom, we're going to do our x to the 5th times x to the 5th. Remember, we're matching what we have on the top. This is the bigger number, so we're going to write the bigger power in terms of the smaller power times another power. And we're going to do our canceling. So we're going to cancel this and this. And over here, we're going to cancel the 2 and the 8, and this is going to become a 4. So what's left is our 4 and our x to the 5th. So our answer is 4 over x to the 5th. Let me write that so it's really obvious. All right. And there's one last type of problem. If you're good to go ahead and do your homework. But there's one last problem that I just want to make clear on, and that you're going to have these on your homework. That it's pretty much the same as the last problem. And it looks like this. So here we have more x's on the bottom than on the top, and more y's on the top than on the bottom. So we're going to need to write this, our x, we're going to have to write it in terms of the x value on top, and then the y in terms of the y value on the bottom times another power. So let's separate that out. Let's do our x's in green. So x cubed in the bottom, because it's bigger, we're going to say x cubed times x to the 7th. And on top, we're going to say, well, y to the 5th is bigger than y squared. So we're going to we'll write our bottom one first, y squared. And on top, we'll say y squared times y cubed. We'll pick a final color for canceling. And we'll say, well, x cubed cancels with x cubed. Y squared cancels with y squared. And so our answer is y cubed divided by x to the 7th power. Okay, and that's where we'll end the lesson. Mr. Lipscomb signing off. And to sign off, we have to always go back to the picture of me for whatever reason, and we will cancel our broadcast. Hopefully this was useful, and because we haven't really done this in a while, we're going to just clap. Talk to you later. See you in class.